Right. So we have a simple problem, merge two sorted list. Here we are given two sorted linked list and we have to merge them by manipulating the pointers in those sorted lists to make a new linked list which is sorted by value. So for example, we have 1 to 4 and 1 3 4, and we need to manipulate these pointers in order to make a new list and return the head of the list, uh, and the list should be sorted. Right. So, but in code, we have a definition of a simply linked list node, which has a value and an X pointer. And in the function, we are given L1 and L2 as two sorted list. So basically, we are going to have these L1 and L2 points to the nodes of these two sorted list and have a runner, which basically will point to end of our answer, and have a head which will point to starting node of our answer and will return this head, and will keep the runner. uh, we will append the nodes from L1 and L2 to the end of the runner depending on the value, lesser of the value between L1 and L2. So let's see how to do this in code. So basic checks, if L1 is none, we can safely return L2 here. If L2 is none, then we return L1 here. Right. So now both both lists are non-empty as of now. Right. So we define our head none, and we return head. We know we'll have to return head in the end. Right. And we need to initialize this head to point to either L1 or L2 node depending on the value. So if L1.val is less than equals to L2.val, we point our head to L1 and we move L1 pointer to point to its next node. And similarly, if L2 has lesser of a value, then we point our head to L2 and we increment L2 to point to its next node. Right. So we have our head defined now. We cannot manipulate our head. We will return this head. So we need to define a runner which will point initially to the head, and while we keep going over the other nodes in the list, loop over other nodes in L1 and L2, we will manipulate this runner. So if L1 is not none, or L2 has some nodes, which means it's not none, we'll keep looping over this. Now here L1 can be none because L2 can have nodes. So if L1 is none, we need our runner dot next to point to L2, and L2 should be incremented to point to its next node. Similarly, if L2 is none, we will point our runner to L1 and L1 becomes its next node. Now both of them has some value, so we need to compare the value, and L2 dot L1 dot well is less than equals to L2 dot well. Runner dot next should point to L1 here, and L1 should be incremented to point to its next node in the list. And this is the last case where L2 value will be less than L1 value, so runner should point to L2 and L2 should become its next node. Now we have updated the runner.next, but we need to increment our runner also, otherwise it will keep overwriting on the same node and basically give us just head and runner, which is two node every time. So we increment our runner here, and we see if our answer is accepted. Let's just run the code here. So output is good. We can also make another optimization that what we have done in the initial beginning, if L1 is none, then return L2. Same trick can be applied here. If L1 is none, then runner becomes L2, and we basically break here, which means runner points to L2 and L2 has the rest of the remaining L2 list. And same can be done here. We can break the loop here. So let's submit this code. Right. So a few seconds ago accepted. Great. Uh, that's it. Thank you. Please subscribe to my channel for more videos like this.